You mind saying a few words, introducing yourself, Marzieh?
Yeah, sure. Hi, everyone. I'm glad to be back after a couple of months. I had a good excuse. I was creating a new human being, but I'm very excited. Yeah. But yeah, very excited to be back on our regular monthly webinars and discussing these awesome new papers that came in very recently.
Rodrigo?
Yeah, hi everyone. My name is Rodrigo Nogueira. I'm a data scientist at NeuroMind. I also collaborate with Zeta Alpha, trying to help to improve the search engine, and also adjunct professor at a local university here in Brazil. And I'm mostly interested in deep learning, information retrieval, NLP, and I'm happy to share here also the exciting improvements that I see recently in the NLP community. Yeah.
Thank you. And myself, like I said before, my name is Sergi Castella. I'm usual in the webinars as well, and I'm an analyst at Zeta Alpha, which means I try to read a lot of stuff about what's happening in the world of AI and machine learning. And every month I curate a list of papers and interesting resources that have happened recently and make some commentary on it. And that's how we base this webinar. That said, let's dive into it. The first I'm super happy to announce this. We're gonna be having a workshop at the Startup Village in Amsterdam. We've been doing this workshop a couple of times in the past, and this is the third edition, which is an in-person event that focuses on transformers and like the state of the art of transformers in various subfields of artificial intelligence. We have an amazing lineup of speakers, among which Marzieh and Rodrigo and some others. So if you haven't registered for it and you're going to be in Amsterdam, or if you want to join online, we're also going to be live streaming the workshop. Please go to zeta-alpha.com Transformers 2022, and you will see their registration page to sign up. And I have to say, I don't know, Marzieh, if you're going to agree with me, but last year it was a lot of fun. I really enjoyed it, and I learned so much, and I'm really looking forward to it this year.
Yeah, I think it was like a combination of coming more or less out of COVID, like one of the first in-person events that we held, and also just the event itself is always very exciting. So often the speakers and the panelists are really good experts in their area, but also the attendees are also a lot of nice experts that live in the area. So either Amsterdam, Netherlands, and it's like a really good place to catch up with people that work in the same field and have a nice discussion with nice food and music.
Exactly.
And I'm very glad that we went with the Transformers at Work title 3 years ago, and Transformers are still very much relevant, and it's a really good sign that it's staying around.
Yeah, it's kind of uncanny how spot on that title was, and how well it has been aging. All right, so please sign up for that because it's going to be a lot of fun. And actually, seats are already filling up quite a lot. I think we're already at 70 or 80% capacity, so you should be quick to sign up for that. That said, let's start with a bit of news. I think that my favorite piece of news that I read this past month that was super interesting was this short blog post from Google AI, where they describe a little bit they make a report about how they're using language models to generate code at Google, and they have their own system that it's not the Copilot, but it's pretty much analogous. And they did a bit of a study on the productivity, and basically some of the headlines. Pretty much my favorite headline is this, that currently 3% of new code that is being created at Google comes from accepting a proposal from a language model. And I believe that, I mean, from talking, I haven't used Copilot, for instance, myself extensively, just tried a couple of times, but from a lot of friends who have used it more often tell me that it's quite a very useful tool. So I would expect this percentage to keep increasing, and that's going to have interesting implications on the quality of code and future language models that are going to be trained on code that was actually generated by language models. And I don't know, I feel like that's an interesting development that has happened so fast, right? Like that this Copilot, for instance, I think was announced less than 2 years ago or something like that, and it's already being used at scale at these big companies. So I don't know, Rodrigo, Marzieh, do you have any opinions about whether this is a good thing or a bad thing? Like is the quality of software gonna suffer from this? Is the productivity really gonna go up?
I can make a comment here. It feels to me a parallel that we have with if you try to code in those low-level languages, and then you jump to Python, you see immense jump in productivity. And I see these systems as a kind of a new language. You're getting more and more in the high-level description what you want, and the model will try to help you. And I see with a lot of excitement, like nobody wants to code in assembly or those very like low level or even C, unless you are very close to the hardware. But yeah, as soon as you jump to Python, your productivity increases a lot. And I think you'll have the same with these models in the future.
Yeah, I like that analogy. Yeah, I mean, it's like there's a lot of repetition in coding, right? And it makes sense that for the like really the dirty work, at least something like this would be very useful. I also don't have extensive experience with them. I just played around with Copilot a bit, but sounds like it's working, so it's really nice.
Yeah.
I think Andrea has a question about if these assistants are popular IDEs.
Oh yeah, absolutely. I think you can sign up for GitHub Copilot. It's currently a paid product, but if you're a student, I believe it's you can get a free license for it. And I think that all IDEs are, I mean, at least for sure, Visual Studio is compatible with it, so you can install it there. I'm not so sure about the other IDEs, which ones are supported or not, to be honest. But I would guess that most of them are supported, or the big ones at least.
Yeah, I have used it with VS Code, so that's something that at least if you want to try, you can use that.
Yeah. All right, so another super fresh news. I think that this came out yesterday. Actually, I was just discussing with Rodrigo and Marzieh. They didn't even have time to see this, so like we don't have a lot of details about this. I was just like reading about it this morning, but I was so interesting that I wanted to include it. So this is a model from this is a new large language model that comes from the Tsinghua University, which is a bilingual English and Chinese model. And one of the interesting bits about this model is, well, first of all, it's released, it's open source, so you can actually go to the repository, you can request to download the full parameters of the pre-trained model. And another super interesting bit of it is that it was designed to fit an A100 or V100 server, so you can run a model on this specific hardware. So it was very much like designed to be able to run inference on this hardware, which I think is interesting from the implications of like how you can use it and like the economy of using this as a product. And besides that, it's 130 billion parameters, which is a bit smaller than GPT-3, so it's like not like a new range of scale or something like that. But they seem to be super effective at training it very effectively, and they do a bunch of new tricks. They use a lot of old tricks, and I haven't looked into the details at all, but they seem to have a new state of the art on the Lambda Zer-Shot benchmark. And yeah, certainly like you should look it up. You can it's on even Hugging Face, so you can even try out some short prompts. And they also have released a blog post where they detail, like one of the most interesting things is they detail major issues that they encounter in training and like how they solve that. They've also said that they're going to release a paper with all the details soon. So we'll be really looking out for that and probably include that in the next month's edition of Trends in AI. Yeah, so I mean, like I said before, I don't think you guys have had any time to read about this, but do you have any kind of questions or anything that you would like to look more into this release?
I don't have any particular comment about GLM, but if you go back one slide, please, there's the Bloom paper, the Bloom model, and it seems that it's worse than the GPT-3 models and OPT ones. I think on most of the tests that I've seen. So it'll be interesting, I think, to to follow up on these, on how they fix this, or why is it the case? Like, is it because they train on the multilingual setup, whereas GPT-3 apparently train only on English? But yeah, I think it'll be nice to see in the future what is the problem with Bloom that I didn't achieve the performance of the other models.
Right. It might be the multilingual, but I believe that they haven't released still like a paper detailing their whole training, right? If I'm not mistaken.
I think if you look at the Hugging Face repo that they put their model, you can see a list of results comparing against GPT-3, and I think it loses for most of the cases. But yeah, maybe it will also be interesting to see evaluations on multiple data sets that might shine better.
Yeah, and we'll also see when they share the more details. That said, definitely check this out. I mean, if you want to download it, it's probably around like 500 gigabytes. So make sure you have some storage disk space on your machine or your server. And finally, some quick news. Some new startup got a lot of funding for basically they're building so these AI21 Labs. They're building like doing research in language models and are going to build products around that. So it does seem like VCs are kind of trusting that this new wave of language models are going to produce interesting, like a very valuable and profitable products. Secondly, the quite famous Andrej Karpathy, who was leading the Tesla Autopilot division for 5 years, recently left. I don't think there's a lot of information on what is behind that, but it's simply like one of these big personalities that a lot of people look up to and follow. And finally, Meta AI finally released this dataset Sphere, which is for knowledge-intensive NLP. This was used in a previous paper that we actually highlighted a couple of months ago, which is called "The Web is Your Oyster." And now you can have access to this data set. So you can just go to their GitHub repository and you will find more information about that. That's it. Quick mention, there was 3 big conferences last month. SIGIR in Madrid, ICML, which we made like a blog piece kind of doing a summarization. That was a lot of fun. You can also check out that on our blog. And then the NAACL 2022 in the US. Rodrigo, I know that you were in Madrid for SIGIR. Do you have any quick highlights from that conference?
Yeah, despite being very hot, it was a super nice conference, and I was glad to see the people all over again after 3 years without attending any conference in person. So yeah, it's glad to see that these conferences are coming back again.
Cool. All right, that's it. I think that this is time to jump into a bit of a short commercial segment. Normally Jakub does this, so it's like my first time. I don't know how I'm gonna do that, but basically for the people who don't know us, we are startup building basically a tool that helps you discover, organize, search through information that's useful for data science and machine learning researchers, like papers, blog posts, repositories, and yeah, basically we have a very advanced, Marzieh could talk about that for hours, I'm sure, advanced search system that you can rely on keywords, you can rely on transformer and semantic search. You can have a whole suite of productivity tools like tagging, taking notes, sharing with your team, visualization. You can search based on papers. You can do like a bunch of like really cool stuff. So you can just go to search.zeta-alpha.com and you can try it out. Other features that we added, quote unquote, recently, not so recently actually now, because it's been there for a while, but you can now have on the platform directly, you can view PDFs and annotate them. You can even like you can even select parts of the paper and use that as a query to find other interesting content. You can also use neural search, which is based on embeddings and transformers to embed basically documents and queries into embedding space and search in the semantics of that. And recently, I think just a few weeks ago, we opened up this feature, which is all of science in your pocket. We called it. We're basically allowing users to do federated search using other search engines so that you can search pretty much any paper that's out there indexed by like Google or any other, or of the like large scale web scale indexes, so that pretty much like you can have access, and you can have access to all the productivity tools through the platform. And also something that Marzieh said that I found very interesting is like this is also a way to realize how good the quality of our search is, because of how bad sometimes some of these federated search can be, which is a very interesting perspective, right, on the feature. So definitely try that out. There's just a couple of examples, but the best thing you can do is to go to our website and try it out yourself. That said, let's jump into the Trends in AI August 2022. Sorry, this is focused on the 10 papers that I selected for the blog, and we use basically our platform. We basically look into a lot of popularity and impact metrics, like how popular papers are on Twitter. We just manually skim through a lot of titles and abstracts of papers. We look into authors' influence. We look into like how popular implementations are. We compile a list that we also try to make a little bit of a variety in terms of topics, because nowadays, if you only looked at the Twitter mentions, we would only get like language models papers. So we also want to like explore a bit of the kind of random interesting topics. So let's just jump into it. The first paper that I wanted to highlight is this called Beyond Neural Scaling Laws, Beating the Power Law of Scaling via Data Pruning. So yes, scaling laws have been very popular, pretty well widely known since 2020. I think there was this paper from OpenAI, right, that discovered these scaling laws. And that's been a topic of discussion in the community since then. So I know, Rodrigo, you've checked out this paper. Could you like give us a quick overview and what your thoughts are on what is interesting about it?
Sure. So I'm glad you put these scaling laws for neural language models slide here, this quick figure. And what this paper, I believe it was released 1 or 2 years ago. And it is super nice paper because it, for the first time, at least that to my knowledge, it shows that how we train these models, we can get equations that tells us what will be the test loss we'll have with respect to the compute that we allocate to train that particular model, or the data set size, or the number of parameters using that model. So it's quite nice to see that there's some equations that we can use to predict what will be the behavior, or what will be the test laws they're going to get in some particular task. The problem with those laws is that they have pre-bed scaling, like namely you need to, let's say, increase your training data set by 10 times to improve only 1 or 2 percentage points in some particular task. And what this new paper tells us is that you can actually do much better by simply selecting better data. And the way they do it, nice things that they found is that it's expensive to select this training data. But as soon as you do it, then your model can do much better. And they do some theoretical analysis on this property, and as well as they also showed on CIFAR10 and ImageNet and some other computer vision data sets that this actually holds also in practice. So I'm looking forward to see the developments, the people, what they develop upon this type of methods. Someone I believe mentioned on Twitter that the next generation of models will be trained based on data selected by the current generation. Like you can imagine some model like GPT-3 generating training data for GPT-4 and so on. And the reason this is a good idea is because GPT-3 might be a good selector of what you should read, what you shouldn't. So the next generation of model might benefit for this selection.
So I think that like a lot of what you say resonates with me a lot, or kind of made me think a lot about active learning and this idea of like models selecting what data should be annotated, or do you know what kind of relationship there is between data pruning or active learning, or like are they actually related, or would you conceptualize them in kind of in the same space?
Yeah, I think it's also in the same space. And another interesting thing is that active learning, you suppose that getting this annotation data is costly, so you try to select what would be the next example to give to your model. And they've also reached a similar conclusion that if you have a ton of data, initial data, you should give to the model only your hard examples, the ones that you think are going to be emblematic to solve that particular task. But if you are in a very low resource constraint, like you have not that many training examples, you should give the model the easiest samples. So that's the conclusion that they have, both in theory as well as some practical in some experimental sessions. So yeah, I think it's a kind of already pretty well studied phenomenon, but I believe we will have much better models in the future simply because the current ones can produce pretty good estimations of what should be a good and a bad example.
Yeah, I totally agree. And I wanted to, before we jump into the next paper, I wanted to ask both of you a bit of a tricky question. I know that like this thing of like to what degree scale is kind of like the most important kind of thing to work on, like, or like the kind of thing that solves, quote unquote, artificial intelligence. What are you guys, what is your, like, if you have to kind of pick a side in this battle of like scale is all you need versus, you know, scale is kind of a useless line of research. What stance do you take, Rodrigo and Marzieh?
Do you want to go first, Marzieh?
Yeah, so, well, I think it's a really nice study, like studying scale and how, like you said, like a lot of the like the nuances and challenges can be solved just by like adding a couple of billion more parameters to the models and things like that. But I also think, like, realistically, it's not something that everyone can do. So working only on this is not really also feasible for moving the field forward. So like people at universities, at smaller companies, the type of resources that they have access to, it makes it almost impossible to work on a larger scale. So I think it will it's still very relevant working with low everything, basically low resource data, number of parameters, things like that. But like good to also have some like overview of what could have been if we had a lot of these resources.
Yeah, I have. I think I see these models as a kind of a tools that we can use. So I'm excited that they can be used to solve many other tests that we didn't thought that it were possible a few years ago. But I agree with Marzieh that I don't think the future looks that bright for. I can do some analogy to people that were working with computer chips. At the beginning, anyone could create your own hardware, and it was possible to put 100 transistors in your circuit. But then with the current processors that have billions or trillions of transistors, there's only a handful of companies that develop these kind of chips. And I think the future will look the same for these models. Like I being a little bit polemical here, I think it's bad news for people who wants to build these models, but it's good news for people who wants to use these models as tools. Like we can, like with computers, as soon as we get access to a very fast CPU, we can do incredible things. And I believe the same will happen with these models. We can now like generate summaries of multiple documents when can create text. I think it's the future. We'll see a blossom of new tests being solved in the future.
No, it's super interesting, and we're going to actually talk a little bit about this paper that proposes a kind of a conceptual framework of how language models can interact, which is super interesting. Oh yeah, I forgot to mention this, but one of the most interesting bits about this data pruning paper is that they propose also a method that doesn't rely on data labeling, right, for doing this pruning. So you can do this pruning on unlabeled data, and they show that you can do that pretty effectively. To be honest, the results are not that incredible. Like they, for instance, show how you can drop 20% of ImageNet data without hurting performance. but it's still an interesting, very interesting direction. All right, so the next step is also a paper that I very much like conceptually, is in the field of reinforcement learning, which I'm not extremely familiar with, but I really like the gist of this paper, which focuses on this idea of like, when you process data, it's just as important, like it's very important to know what you can throw away and what you have to focus on, right? Because most of the information you're getting, or an agent is perceiving from a state, is pretty useless, or is either it's useless. And in this paper, they categorize the uselessness by saying, okay, there's like information that an agent in a reinforcement learning setting, there's information that is not controllable, like say like the weather, for instance, in a state. So there's information that's uncontrollable, information that's controllable, and there's also information that's relevant for the reward, and irrelevant for the reward, right? And the information you want your agent to focus on and to learn from is that information that is both relevant for the reward and also controllable. So they set this up in a way that they can learn representations of states and disentangle these types of like this information that is controllable and uncontrollable and relevant or irrelevant for the reward by using some information theoretic principles of like how predictive each part of the representation is going to be of the others. And basically this allows them to learn more efficient representations. And one of the easiest, the best ways to see this is by looking at this GIF. For instance, they have this agent that is walking, and then they add, they superimpose in the background, they add a background that is completely kind of irrelevant for the task of having this agent learn walking. And if you look at the rightmost, the Denoised MDP, you can see that the signal representation learns a representation of the agent and kind of learns a representation of a fixed background, which means that it's kind of identifying that as noise and not using it for modeling the policy of the agent. And I think that conceptually that is super interesting, and you should look it up, this paper, because it's a super interesting kind of concept and kind of permeates the whole, I think, machine learning kind of, it's all about determining what is noise and what is signal in a way. All right, the next paper is also kind of a hobby horse of mine. I feel like I really like prompting, and I've been always highlighting some of this work because I think it's quite interesting. Since I think a couple of months ago, I mean, it all started a lot with GPT-3, and then a lot of other people picked up this prompting thing and kind of built up a lot of ideas on top of it that have been quite successful. A lot of them coming from the Tsinghua University. So they're actually the GLM release that I discussed later. They're also doing some prompt tuning thing there, and they have a lot of expertise in this area. But I think that I think this is the first time I've seen this in information retrieval or text retrievers. I don't know if Marzieh, you can correct me on that, but maybe you can guide us a little bit through what they are doing here, Marzieh.
Yeah, sure. So the idea here is that there are like a couple of challenges in using neural model in text retrieval, and they mostly want to focus on the first one, which is the parameter efficiency, but also like as a side effect, they show that it works well on generalization and zero-shot retrieval as well. And what they there's a nice figure in the paper that it's not here, but you can check it out, that they show that there are different ways of basically having parameter efficient methods, whether to have like insert an adapter in the transformer, or something called the bit fit change, or what they focus on is a prefix tuning, the P tuning they call, where you basically fix the weights of part of your model and only at the fine-tuning step only tune part of these parameters. And they show that it can achieve comparable results with just fine-tuning everything, so like a full parameter fine-tuning. And so the nice thing is that, so basically there is this like compromise of quality and the number of parameters that you have to basically learn. and they show that they can meet this basically this compromise. I think so there exactly. Thanks.
Yeah, I just wanted to show this. I think this is the figure you were mentioning, right?
Yeah, exactly. Yeah,
and of the different
which I think like the different parts are also would be nice to focus on, but they mostly focus on the p-tuning.
On this.
Yeah, and they show that also in terms of generalization, it works on both the cross-domain generalization and cross-topic generalization. And so here in the table, you can also see how it compares with the more traditional BM25 search, and also like in comparison with the fine-tuning approach.
So in broad strokes, what is your kind of opinion on prompt-based learning, or like this whole line of work? Like, are you hopeful that that's gonna kind of become the dominant paradigm for fine-tuning, or do you think there's still gonna be kind of both things coexisting, as in like full network fine-tuning and prompting?
Yeah, so well, we have with Rodrigo and some of people at his university, we have also worked on something not quite similar, but like working with prompts and how we can benefit that in text retrieval. So yeah, that's a good question, and it's something that I think I'm also on board with you, what you said about how these prompt based approaches are promising in NLP and also in IR recently, and definitely a good way of exploring whether it's like a new types of data that you can generate with them, or like with these like partial training of the models. But it's also like a bit, I don't know, with manual prompts, I'm always like a bit wary of being careful of how much our own inductive biases are put into these prompts, and how we can avoid that and have a more general, basically, definition of prompts. What do you think, Rodrigo?
Yeah, I have one comment here is that it's funny that when I did my engineering school, and engineers are famous to not write well, like they write like confused sentences and everything. And I believe more and more, and it's good if you're a good programmer, like people didn't care that much if you're a good writer. But now with these prompts, I think that'll come back at us. Like we have to write well, and you have to be precise in your definitions, otherwise the model gets confused. Like, I think it's an interesting future that are gonna see people that can communicate better with these models. And I see prompt engineering as also a weakness of the current models, that we need to be so careful expressing the same thing. It gives us different results. Semantically expressing the same thing, but with two different prompts, it can usually give us very different outcomes. But I believe this is more a weakness of the current models. And if you take the newest ones, like the GPT-3, DaVinci 002, it doesn't get that much confused, and I believe in the future less and less. Yeah.
No, that's fascinating. I mean, it does sound like it's very much a skill, right? To learn to interact with these language models and kind of like get a sense of what breaks them and what makes them output, what you want. So speaking of large models, this is a paper also recent from the past month from Microsoft. So you might have heard about DeepSpeed. So DeepSpeed is this library for high performance or like large scale training of transformers. So this was used, for instance, by the Bloom language model, which is a 176 billion parameter language model. So they originally specialized in training. So this was a library for like training across multiple GPUs in clusters and like large scale training of transformers, and then they also released a new component for compression of models. And this latest addition, which they have a paper outlining, and they also have a release notes and this library actually that you can just install and use, which is for inference. And it's super interesting because in the paper discuss how transformer architectures have diversified quite a bit, especially in the space of large scale models. For instance, mixture of experts have become quite popular, which is this style of architecture where you increase the number of parameters, but during inference, the input only is routed through a subset of the network. So the actual weights that are used for inference are not the whole network, but only a subset. And this allows models to retain a very big expressive capacity, but keep the inference costs still kind of more manageable. But these models are very hard to implement because like different parts of the model are stored in different parts of a like GPU clusters, and like managing all of that, you need like a lot of optimizations to actually make that run fast. And that's pretty much what this library does for you. So if you happen to be one of the few people in the world who is actually hosting and running these very large models, this new inference library from DeepSpeed is gonna let you have. They claim in their paper that it's up to a seven-fold improvement in latency focused applications across like a wide range of transformer architecture, like dense and sparse mixture of experts, and then a 1.5x improvement in the throughput speed up. So the paper contains a lot of the kind of details about scheduling and CUDA cores and kernels, like all of these kind of things. So if you're into that, dive into the paper. Is quite interesting, but at the same time, being realistic, probably most of us are not gonna need to run these models ourselves, probably. So we're not gonna have to deal with this complexity. But I don't know, this might change. Do you guys actually think that? Do you think it's gonna become common to host these large scale models, kind of by smaller companies or universities, or it's gonna be mostly and kind of black box API kind of interaction with solutions like the GPT-3 API or others?
Yeah, that's a good question. I really don't know. Yeah. But one thing is, I believe in the future we'll have these smaller models. We'll be able to have a much better model with fewer parameters than we currently have, or at least the serving cost will be smaller. Because this is a more necessity, like we cannot afford to pay whatever OpenAI charges us to use their model. And yeah, that's my take, at least. Yeah.
So as long as OpenAI keeps their prices very high, people are gonna find a way to host them themselves.
Yeah, maybe. Oh yeah, that will build pressure to at least use I don't know, cheaper hardware to serve ourselves.
Would you be excited, Marzieh, to actually like have host our own billion scale parameter models?
Yeah, I think it really depends, right? So the alternative is not cheap, but this is also like it has its own complexity. So depending on the use case of the model, I think that can be a possibility that at some point we or some like other smaller companies like us would want to do this.
Mm-hmm. Cool. We can ask. Go ahead.
Yeah, I was making some calculations. So if you buy a ton of these old GPUs, like the K80s, like you can buy one K80 for, I believe, $200-300 on Amazon these days, which is a fraction of the price of the newest GPUs. And then the idea was to serve GPT-3 using these pretty old GPUs. But then if you do the calculations, it will spend a ton of energy, like paying for the kilowatt hour. So yeah, that is still not a single easy solution for it.
Yeah, and I'm wondering how, I mean, I really don't have any idea of the ballpark. Like, I've been quite surprised at how fast actually doing inference through the OpenAI GPT-3 or like DaVinci API. It's like pretty fast. I'm wondering, like, Do you guys know actually how they make it run that fast, and like would that be replicable on other hardware, or just?
Yeah. From my calculation, I believe if you run, for example, have experience with GPT-J, which is 30 times smaller than GPT-3, you can run more or less one example on an 800 on GPT-J. So if you want one example per second on a 800, so if you want to go 30 times bigger, probably you need another 30 800s to keep that same throughput. So yeah, it's a ton of GPUs, I guess.
Yeah. So maybe not for real-time applications for now, but we'll definitely keep an eye on the space, and maybe we can ask for a budget to Jakub to let us host one of these models. All right, jump into the next paper. Language models mostly know what they know. So this is a paper about calibration, right? Language models, which is arguably it's as important, if not more important, than performance itself, right? Like having a reliable assessment of when models are gonna produce truthful results or when they're gonna produce garbage. So Marzieh, can you like give us a short summary of this paper and like the main findings?
Yeah, sure. I think this is a really nice paper and an easy read. So I would really, if you are interested on this topic, I would really recommend reading this work. So the main focus is, like Sergi said, so how can these models make calibrated prediction? And if just for those who are not aware, what it means is that if the model basically so a model generates the responses, whether it's like answering questions or the generation itself, with a probability, and it assigns this probability to the outcome that it generates. And if this probability coincides with the frequency with which these outcomes are actually generated as like the ground truth, that it means that the model is calibrated. And what you see in these figures as well is basically the dashed line, which means like a very calibrated model. And the idea of this paper is to study language models with different sizes and see how well calibrated they are. So in a more like intuitive way, you can say that how whether these models are aware that they are making mistakes or not, and whether they can identify their own mistakes. So after basically generating the answer, whether they can say that whether that was a correct answer or not, and things like that. So for to study this, they actually look at 3 different settings, let's say, experimental settings. So the first one is they actually look at multiple choices and see basically just these models, how they do on different, so this one is the big bench data set. So you see that as the size of the models get larger, the models get closer to the well-calibrated line, but smaller models, not so much. Then in the next experiment, which I think is interesting, is that they replace one of the answers in the multiple choice with none of the above. So it adds the uncertainty, or basically it adds the option for the model that if the model is not sure of the answer, it doesn't just randomly pick one with the low probability, but actually chooses this answer. And with this option, the models are actually shown to be not really well calibrated. So especially if, they look at the Zer-Shot, but once they show more, they generate more samples for that, the models get a bit better at this one. And then there's a true-false one, which was, do you remember, Sergi, how was the experiment designed?
I think it was like the same bench multiple choice questions, but kind of reformulated so that there was a sentence like picking one answer, and then the model would output whether that was true or false, I think. So it's basically kind of like a reformulated multiple choice.
So the self-evaluation one, right? I think.
Yes.
Yeah. So that Yeah, so that's the part also, like, this is also like also going back to this talks about scales. Here you can see that how smaller models are not, basically they are not confident, or they are like overconfident in their own answers, and they cannot identify whether they know something or not. Yeah, so if you go to the next slide, the second set of experiments that they do is that they, without any fine tuning, they want to see if these models are good at self-evaluation or not. So basically, given a question and multiple answers, the model would pick one answer. And then the next question is that to ask the model like whether this is the correct answer for this question or not. So then the answer would be the true or false. And yeah, in that setting, it also shows that if there are few examples given to the model, then the model, well, if there are no examples, then the models are not confident enough. But once you actually give them a few examples, then they can self-evaluate better on the examples that they see. And then the last part is where they fine-tune on the, so they have this probability of I know on top of the, basically the last layer of the language model, and they fine-tune that by asking the model basically to literally say what is your confidence in generating this answer, like giving a percentage of confidence for that one. And if you train, so there's a figure on the right with the red and blue one, and you see the blue one is trained on all data sets, but red on only one data set, the trivia QA. So I think it's an interesting one that if you see how, if you diversify the data that you see, then the model is getting better, more or less, at its estimation, but it can become overconfident. So like if the data set is not diverse, the model is underconfident, and then if it's diverse, it's overconfident. So it's also like interesting to basically look into how these models think in a way.
Yeah. No, I think that the whole issue of calibration is super interesting and relevant, especially when you start thinking about how you can apply these models into a real product, and you want to have some guarantees, like, you know, that they cannot be right all the time, but if you have a good estimation of how, when they're wrong, when they're right. So I mean, it does seem like from this paper that there's still kind of a long way to getting properly calibrated or like trustworthy in that sense models, but it's very nice to see progress on that. So I would love to talk a bit more about this, but we are running a little bit short on time, so I want to quickly talk about a couple of last papers. I don't want to spend a lot of time on this one. It's super interesting. It's about object tracking. The authors propose a new architecture, unified architecture for object tracking, and basically they achieve state of the art on a bunch of like a lot of benchmarks. Like their benchmarking suite is quite impressive. You can see here that this was published only a few weeks ago, and it already has more than 600 stars on GitHub. So I think that the implementation is becoming very popular, and if you're working in this space, you should probably definitely check this out, especially the implementation. Here you have some benchmarks that we don't have a lot of time for, but next one, scaling laws and model architectures. This is again a bit discussing a little bit this thing about how models scale, and the thing that they look at, which I find super fascinating, is architectures and how they scale differently. And the reason why I think that's super interesting is because during the past year, I feel like we've seen so many new papers of like, okay, MLP mixer, like now it turns out that you can train an MLP-based massive model, and it performs great on images. And then someone else comes out with a new CNN-based model that just performs just as well. And another one comes up with a transformer-based model. So it feels to me like in the past year, there's been like a lot of explosion of new architectures that kind of classically people would have assumed would not work well for a certain application. And then it happens that when you make it big enough, it kind of just works well. But there's a lot of caveats. And I think that this paper touches on that. And I think that's super interesting. So Marzieh, I think that you want to check this out.
Yeah.
Can you give a quick?
Yeah, very briefly. So this paper comes up with a couple of questions and it answers it very clearly. So it's like a really good read for that. So the main question is, does model architecture affect the scalability of the models? And then if it does, how then does it influence the upstream and the downstream tasks? They basically look at the transformer model, the vanilla one. So in all of these figures, the green line is the vanilla one, and a lot of other transformer models. So the Albert, the performer, so whether the transformer is optimized or like all sorts of variations. And so there are two clear patterns that we see here. Oh, and by the way, so the settings of the experiments are also like very much unified, like fine-tuned on like exactly the same number of training steps for every model, fine-tuned on a mixture of glue, super glue, and I think squad, and also evaluated on the downstream task of the NLU task of these. And then you see that there are a couple of interesting observations. So one is that the vanilla transformer, it actually scales really nicely. So going back to the previous paper that we were talking earlier, like with increasing the size, it improves the performance. Another interesting bit is that a lot of these variations of the transformer model, they start more or less at the same level with the vanilla transformer, but they might not scale as well as that one, depending on the model. So you see different behaviors on like performer, it basically doesn't really scale as well, Albert as well, but then things like the funnel is like really scaling well. So it is very clear that there is no like one recipe for all and one decision for all. So depending on the model that you are using, then you have to see like how and if you want to scale or not, or which one to use. And if you go to the next slide, so this is for the upstream task for the pre-training, and then they look at the downstream task of basically the transfer learning of these models. Again, you see like different behavior from different models. So it's not really, so it is important when we talk about these models, it is important to individually see which number of parameters we want to use for which setting, for which data set and experiments. And it's not really going with one. And it's also more or less clear why a lot of people who also work with want to pick up like a state-of-the-art model, they go with the vanilla transformer because it's like really robust, it scales well, and it's still very much relevant.
So takeaway, if you can, like, what are the two main takeaways, like two one-liners that people should kind of take home from this paper?
I would say that the scaling laws that maybe we talked about, that it's like really nice laws that applies to everything. That's not the case for it. It really depends on the architecture of the model that you're using. So be wary of that before going scaling and expect like everything to gets better with scaling.
Cool. All right, very quickly, the next paper is a very big jump in terms of like the kind of line of research. So discrete key value bottleneck. I wanted to highlight this paper because it kind of goes in this line of research that I think is quite interesting. I mean, the paper itself is interesting, but I think that this line of work has been quite interesting from both Yeshua Bengio and Bernard Schopkopf. Probably made a mess there. But anyway, it's like it has been quite controversial, but also quite popular. Like this line of work that tries to basically Benji expressed this in like a position paper back in 2017, and also Bernard also has his own kind of position paper about kind of like the research agenda that they're following, and it's this idea of kind of inductive biases that are very much focused on imposing bottlenecks on the information flow so that you get representations and models that are more robust to kind of a generalization in kind of out of the main setting, and also kind of learn more the causal structure of the world, which is a very ambitious thing. Also not so popular, I think, nowadays in machine learning, but I personally think it's super interesting and worthwhile of consideration. Rodrigo, I think you checked out this, you have time to check out this paper?
Yeah, it's super interesting one. Yeah. So what do we normally do with these models is that we have this encoding step, which is represented in this figure as the step 1, and then we go directly to step 3. Like we take a string, let's say, or an image, convert it to a vector, and then we want, let's say, to predict some sentence based on the input sentence or the input image, and then we use a decoder for that. But these models, they act in this continuous space. And what they argue here is that when they work fine if the training and testing distribution are the same, but as soon as you see different examples than the ones you saw during training, these representations, they shift and the entire model breaks. In other words, it underperforms in comparison to the in-domain test data. So what they propose here is to ground the model with these symbols. They have this code book that maps from key to values, but the point here is that these symbols are fixed. You learn them during your initial training, and then you can apply some fine tuning, but you have to reuse them for many different examples, which makes like as if you had only a set of variables that you can use, and you're not free to randomly walk into your continuous space. And I coming from the information retrieval field, I think it is a very nice connection to what a debate that we also have currently in information retrieval. Should we store the documents as vectors, continuous vectors, like a neural network could easily output, or should we store them as symbols? Like we can still use a neural network to given a document, but output a new set of symbols that and these symbols will be the ones that will be stored and later retrieved. And currently, it seems that storing them as symbols, what we call the learned sparse representations, seems to outperform the dense representations in these out-of-domain settings. And I think this paper gives us this nice connection and intuition why that might be the case. Like you always want to see some grounding knowledge from what you saw during training. So yeah, I think it's a super cool paper to read.
That's super interesting, especially this connection that you mentioned to information retrieval. That said, we only have a couple of minutes left. I wanted to quickly comment on this one. This is also kind of a strange, yeah, not very common paper. It's called Language Model Cascades. I think, Rodrigo, you also checked this one, and I think it very nicely kind of talks about a lot of things that you have mentioned you're interested about, basically using language models as kind of a tool to build other models, right? And like how these models interact and this kind of a formalism for expressing that. What do you take from this paper? Do you think it's kind of a useful framework conceptually, or like do you think it can produce? Yeah,
it's nice, always nice to see this formalization of the models, and I take away here is the same. Like we can reuse either the same model or different language models in this continued chains of processings until you get to your final answer, the things that are actually interested. And yeah, each one of these nodes, you might treat them as black boxes, and you can change the prompts, but then you're reusing the knowledge acquired by these potentially very different models to reach a conclusion. Which I think is fascinating. It's like you can ask multiple experts or a cascade of experts to reach your answer. And yeah, it's
no, I couldn't agree more that this I totally expect this to become a way bigger thing and more common thing of like kind of using models as building blocks and kind of like treating the bigger model as a kind of from a higher level of abstraction, I would even say, or something like that. Although that also opens a whole lot of problems about explainability and like a lot of things that also need to be taken into account. It's going to be super interesting area of research. I'm pretty sure. And finally, super quickly, just 30 seconds. This is a new method proposed for learning representations that are graphs of primitives. Basically, the idea or the main objective of this method is to be able to learn new concepts at inference and learn structured representations of images based on like primitives of like lines and how they're positioned in space and represent that as a graph. It's like not super impressive from the perspective of results, because it's like even in the results, they don't really have very strong baselines to compare these two, because it's kind of pretty like novel approach. But I think it's a very interesting kind of first step in this space of hybrid AI, where you try to kind of mix the kind of like structured representations and more like symbol, close to kind of symbolic approach to representation learning with the learned representations from like more the machine learning tradition, and kind of like find something in between that I think is quite interesting. Only time will tell if these things become kind of pan out as something useful, but definitely an interesting read. Some GitHub highlights, YOLO v7, the unicorn, the unified object tracking that I mentioned before. Definitely check this on our blog. This is all highlighted. And as a last reminder, oops, I forgot. Oh yeah, this is what I wanted to finish off. Sign up for the Transformer event. It's gonna be a lot of fun, so definitely check that out. And I'll see you in September there. That's probably the next event we're gonna have. Any closing remarks, Rodrigo, Marzieh?
No, I think, yeah. Thanks for the invitation. It was super fun to participate here.
Yeah, exactly. Thanks, and I look forward to see a lot of people in person at our event.
Thank you for joining us, and yeah, see you in the next one. It was a lot of fun.